মোবাইলটা তোমার হ্যাঁ So now in this section we will see some more question on set formula evaluation. So this is a CNF, right? Now CNF for conjunctive normal form. Now if I put true, false, false, true, false, true, false, true, and true, false, true, false, true, and true, false, yeah, that is same. So if I put this, then first of all, what is the number of clause in this formula? 1, 2, 3, 4, 5, 6. There are 6 clause. So if I put this value, then how many clauses will evaluate to be true? The answer will be 2. Why? So let's see. If I put for A or not B, so if I put true, this one is true, and or false. False means 0 and not B means not 0 means 1. True or true. So it will evaluate to be true. So this is true. Next, not true. False or false. This was to be false. Next, false and false or false. Again, this will evaluate to be not true. About this, false or false, again not true. Then false or false, not true. And true or true, this will be again true. So there will be 2 clauses which will evaluate to be true for this value. And we can carry out this calculation, and we can write the heuristics function. How many clause will evaluate to be true for a given string? So only this 0 to false, false, true, true, false will evaluate to be true in all of these cases. So that is what we wanted. We wanted the heuristics function which will evaluate to be true for all the clauses. So next question is, hill climbing method and best first search. So hill climbing is like local finding local optimum only, because hill climbing does not guarantee that it will give a global optima. Let's see. If you do this hill climbing and starting node is B, then you will get only A, C, D, E, H. Why? You will see right now. Starting from Starting from B, A, C, D, E, H, this will return hill climbing, right? Next, what will be the heuristics value of the node ABH, ABC? Heuristics value of the node, uh, if we calculate it, I think it should be 65. Heuristics value of the node of A, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 into 5, 65. This is the Manhattan distance. Heuristics value is using the Manhattan distance. So for A it is 65, for B will be 75, because why? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16. So 16 into 5. Yeah, that's it. Uh, 16 into 5, it is giving me T. So I need to find out. It should be 15 only. Let's see. 1, 2, 3, 4, 5, 6, 7. Right? 8, 9, 10, 11, 12, 13, 14, 15. Yes, 15. 15 into 5, 75. Correct. For C, it will be 100. You can calculate it. It's just for every step you will count 5 because here it is 5 and 5, 5 into 5 in size. So going through the y-axis, you also add 5 units, and going through in the axis, you also need to count 5 units. And after after getting into the destination, you can count just by adding 5 for each unit, for each grid. Now we are going to compute the heuristics value of the node FGH. Goal node, it will be 0 for H is 0. We can do that. We can do all of these things. Our question is, in a map list the 7 node inspected by hill climbing algorithm. So starting from S. So from starting from S node, it will go to M. Why? Because from the without even calculating the heuristics value, you can just directly see that from S, which node is closer. I mean, hill climbing search algorithm will trying to find out which is most closer to the goal, and it will see that M is the most closest, right? I mean, so from S it will go to M. Then it will see that, well, J is further away, but P is the closest one. Then it will go to P. But it will not return because it is hill climbing. Why? Because if it need to be returned, then it will see that I need to go to M again, or I need to go to M to go to J, then H, because it does not see that there is no part from P. It just see that what is the optimum value present right now, and not globally but locally. So that is how it going to find out that its part is just SMP, because from P it will not going to go anywhere else, it will stop there and the result will be just SMP. So what is the path found by hill climbing algorithm? So path is start to goal. So hill climbing algorithms start with S, but it does not go anywhere. It just stuck there. So answer will be nil. At base first search will find that because it will go to SMP, then it will go to J, then HKL. You can see here S, then MP, then it will again go to J because M is already seen. That it will directly go to J, then H, then K, then which is the most closest? Well, O is not the closest, so it will go to L. Then it will okay. Now it's time for O, then N, then G. So SMP JHKL, it will go to J, JHKL. But the first seven node will be like this. But then what will happen? For first seven node, we can calculate the heuristics below now. What is the path found by base person? So SMJHKONG. This will be the path found. SMJHKONG. This will be the path. Next question. Next question is an probability and so the probability of occurrence of 6 objects are given below. Now it may describe 6 dices are A, B, C, D, E, F of a population of 6 distinct individual of generic algorithm or any situation in the 6 subjects. Now let us assume that above definition for 6 decided dice. In a real dice 10 times, you get exactly 10 alphabet instances. According to table of probabilities, if we throw the dice 10 times, then the expected number of occurrence of each alphabet is so for each one we can calculate the expected value. What is the expected value? Expected value is just nothing but n multiplied by for each probability. If we multiply each probability when we get expected value for each alphabet. For this it will be 1.1, this will be 1.2 like that. Next question. In 10 throws, some alphabet may or may not occur, but when alphabet occur, they will occur in a whole number, not fraction. Okay, you can round up to 1, 2, 3, like that. Now for 10 throws, sum of the rounded AX value tells us how many alphabet duplicate you can expect in 10 throws. The expected number of alphabet duplicate is the sum of rounded. If you sum it up, this 2 plus 2 plus 2, 6, 7, 8, 9. So this will be 9. Next, if we throw the dice 60 times, an expected number of occurrence of so each alphabet is just multiply with 6. The current expected value just multiply with 60, it will be 6.6. Then it will be 7.2, something like that. Rounded value will be 6. Next 7, then 7, 7, 7, yeah, 7, 7, 7, 7, yeah, up to 14. Next for 60 throws, sum of rounded value will be 61, correct? Does it match 60? No. If it does not, how will you address discrepancy? Now consider the same probability distribution or compare the cumulative distribution. Well, we will see later about the chemical distribution. Now we need to see what is here. And this is because we can see in this. Well, this is also one kind of heuristics functions where we have uh, tried to figure out how many for each bit string or each 5-bit string. After doing one exchange, just we change 1 with 0. After we can change this. So if there are 5-bit strings, we can change one at a time, and we can do it to the power 5. Right? I mean, we can do only this for each one, only this only. So okay, so let's see how many clauses will it evaluate to be true for 10101. Then we change this 0010. So here it is given for 00101, the clause it will evaluate to be first one, second one, third one, and fourth one will evaluate to be zero, to be false, and fifth also, and sixth one is so 1 2 3 4 4 clauses will evaluate to be true. That's what it is written. Next thing is, if we change again 10 from 10101 from 10101, and then we get two value, because here it is we are going to take in taboo search we are going to select uh, the two value which is most optimum. Here you can see there are which gives the this is a maximization problem overall. So in this maximization we get the three value which is mostly optimum 444 maximum value, but we will select the first four which go according to the lexicographic order. This is higher, so we will select this one and this one, and then we will calculate again one more we will change one more string, one more bit of character, and then say check how many clauses it will satisfy, and then sum it up to check what will be the heuristics value of each of this number, each of this string, and we will get this heuristics value with 2, then again 4, 5, and then from these two we will get we will select the most um, optimum value, which is nothing but 5. Maximum value here is 5, and from here we will select uh, according to lexicographic, we will select only 2 according to lexicographic order. So that will be the most lowest will be 00001, and then the next one will be 00100. This. Okay, it was about Question number 16, practice number. Next, well, the part, next, it was the part, like, what will be the value it will take from as was 95, and it will take the value, the open, the value n, then in the n you can see the lowest value is m, so it will go to m. First we need to calculate all the heuristics value. For goal node it will be 0. Yeah, for C it will be 100. You can see here. No, for N it will be 100. C it will be 90. This is a critical question. And we can select the path for best first search. It will be S, J, I, E, F, K, M, G. And why? Because we will go first to S, because we are going to start from S, right? From 130. Then what will it will open to? So you can check it out. So, okay, let me check. Okay, let me check for you. Okay, so from S it will go to, I'm going to use one distance, BEJO. So these four things is possible. Where it will go to? It will go to the most lowest one, which is BEJO. BEJO. The lowest one is J. So as BEJO is opened, then it need to go to where? That is going to, B, that I'm not getting. Then E. Question number 1. Question number 1, we have to respect it by breadth first. Okay, it is breadth first as algorithm. Also, it will work according to the breadth first also work according to just only how the nodes are inserted into the open list, nothing else. And in breadth first search, you need to select not like and best first you need to select like this, open BEJO, like BEJO, first B, then it will go to B. So from B it will say I opened EJ, because the from B you can see that the next node is open is A and F, and A first then F. Also there are other value but I as B, but they are already in open list, so it will not consider to write again in open list. So it will just say A and F according to alphabetical order, and then it will it is what best first search, right? So they will count at the last algorithm. So uh, it will go to B, then open will be EJOA, then F, EJOAF. OA here it will be F. And then it will go to E, because it is alphabetical. E, then it will open, and you will say JOA is or AF already there, and I have already seen I. So it will write it as I, then it will go to J, then open. J will say that I do not have anything uh, to further because already are in open list. And it will go to O. O will say yes, I have one. It is called N. Then it will go to A. A will say that I also have one, which is C. Others are already in the open list. Then it will go to F. F will say I have one. It is K. Actually, F does not have K, right? F does not have K. Yeah, F does not have K right now because F cannot see the K. F cannot see the K, so F does not have K. Or does have K? Yes, F have K. C, F will say I and C, then K. Yes, I and C and then K. Okay, okay, fine. Then I and C K because I do not have much thing to do, add more. Then it will go to N, it will say CKMP. I mean M and P will be added from N according to alphabet. Uh, and then it will go to C, then C will say I have only one thing to add, it is D. And from K it will just go MPD, and from M it will directly go to Z. So we can see here the order in which it will find, right? S B E J O A F, S B E J O A F. That's the order. And from for question 2 also we can check which node has the largest heuristics value. If we calculate it, we need to calculate it from every heuristics value, and we will get that B has largest heuristics value, which is 160. Now, what will be by the best first algorithm? So for to use base first algorithm, it will just check as J I E F K R. Now you can directly check as next it will select J. Why? Because J is lowest. Next lowest is I. E will be next. Here it is not hill climbing on nearest neighbor. That is why it is searching. It is going to E, even though from I E is not optimal. Okay, so then from E it will go to F, then it will go to K, then it will go to M, then it will go to Z. That's it. S J I E F K M. Next question they are asking, as for the hill climbing algorithm, what is the well hill climbing algorithm will do nothing again as JI only because E is 120, it will not go to 120. And what about the base neighbor search? Well, base neighbor search will also just oscillate in JI, because for J it will be the I will be the base neighbor, then it will go to J, then again it will go to I. That's it. For depth first search, we can again we will be able to see that for S it will again select the alphabetical order B J O, then it will go to B. B will say that I have uh, for B, I have open only A. So A will come in the beginning. So then again, A will say that I have uh, C and F. So CF will come in the beginning. Then C will say I have D. So then D will say C. That's it. Next question number 8. For a given map, find a TSP tool only using. So there is definitely more than one tool. Why? Well, we can see that like for from S to S, if there is a part where we can go without crossing or without doing a cycle, that means TSP exists. A tour exists. A tour exists. So there are a lot of path. This is also a path. This is also a path. So there is more than one path. Next, we need to construct the heuristics value. We can see that directly. The value will, yeah, we can see that directly. Okay, now so if we see that a tour of 15 cities shown in big where needed A, B, C, D up to O as index sequence to prepare tour representation. Select the valid part representation of the tour. Well, this is the path representation FLAME. We can select start from FLAME up to again up to DIC. This is also valid. Then LAME. Then again go to F. This is also valid. Next, adjacency representation of the tool. So how do we select the adjacency representation of this tool? So we can select any of this. Then what we will do? We will write it as like this: A B C D up to P, and then we're going to select where it was given. Like uh, if we select as we from the graph, we can select that uh, from A it will go to M, right? From A it will go to M. So then from B it will go to I, right? From B it will go to I. So just like that we will select for each value A for A, B, C up to O, and then we will just put this value in the new part we are going to create, and it will be called as adjacency representation of this part, where for F it will be M. You can see here. For F it will also be called as L. So but MIDF, right? So it should be M. So A will go to M. Wait. MID. MID. It's just that we will write exactly as it is from where the adjacency tool will be. Just we are going to write it as MIDF BL, just as it is only. MIDF BL OCNKH HAE GJ, just like it. And we're not going to do any further calculation on it. It's just from where m is coming from A. So we will just write it as that m, then for B where it will go I, so mi, for C where it will go H, so mi a, for C it will go to D, so mid, just like that. Next is the ordinal representation. So for ordinal representation we can just calculate the mm, we can just calculate the number for each number. For A it will be 1, then for B it will be 2, just like numbering. We can do that.